As we begin our force unit, we're taking a look at what variables affect acceleration. In general, we know that you need a force or an unbalanced force to cause an acceleration, but how increasing that force or decreasing it, or if there's any other variables that matter, how that affects something's motion is a little unclear still. So what we decided to do was test what would happen if we changed the force we pulled an object with, what would happen if we changed some other variables. Here's the basic idea we started with in class, that forces cause accelerations. And we started asking questions. What can we do to make something accelerate more? And we came up with the idea, add more force. And that eventually led to the idea that force probably is directly proportional to acceleration. If we increase force, we expect something to accelerate more. Now that's just a hypothesis. We actually have to check it in the lab we're going to do. The other variable we considered was mass. And we thought about mass being laziness. If somebody's more massive, that's probably going to be less acceleration. If they're less massive, it's probably going to be more. So we decided that mass was a variable we should check as well. Now you can only change one of these variables at a time. So the first experiment we're going to do is vary the mass of somebody riding on an object and see how that affects acceleration. And then we'll go back and we'll look at the effect of force on acceleration. So the basic experiment we're going to have is we're going to have somebody pull another person down the hallway on this low friction cart. These are rollerblade wheels. So we can keep the force of friction as negligible as possible. We're going to be able to measure the force people are pulling because we've got this old fish scale, which can measure up to a 30-pound pull. So in one of the experiments, as we discussed, we'll be keeping the mass of the person constant and pulling with different forces. In the other, we'll do the opposite. We'll keep the force constant and we'll pull people of different masses. So I want to show what one such pull looks like. And my friend Mr. Sember helped me do it. Hang on one second. So Mr. Sember has volunteered to pull me, and he's going to pull me at a constant force of 10 pounds, and we'll see what constant acceleration looks like. Whee! So on the next slide, you're going to see some data from one of my classes of how mass affected acceleration, and then you'll see a graph, and we'll take a look at what that quality looks like.